Hey, all my JavaScript friends, this is the Virtuoid, aka Mike Smith, and this is the Fun with JavaScript video series on our dice. If you like this video, please click on the like button below, subscribe to this channel, or leave a comment. I would love to hear from you. So we left off with our last video and with our test. We got all of our tests written. I still have it up on the screen here. There, that looks prettier. Okay, so we got all our tests written, so now we need to write the code to match the test. So we're going to create a source directory. And that source directory has now been created. And within that source directory, we're going to write our dice class. Export default static class. Oh, that's right, I can't do static class. I don't know why I did that. Class. Other languages, messed myself up there. There, we have now written our dice class, the very easiest, simplest dice class you could possibly ever imagine. So, what do we want our class to do? Well, first of all, we're going to have a constructor. Oops. It won't accept any arguments, but will throw an error. And that error basically is you cannot instantiate a new dice class. Use a static methods instead. Our static method is called roll. And we'll be passing in an equation that by default is going to be blank. So that's pretty much it, right? Yay, we're done. Now we got to write all the innards to the code. So we got to kind of start talking about how we're going to implement this particular code here. So the idea here is that we're going to parse out all of our code, and the easiest thing for me to try to work with as I'm working on this is that I want to try to separate everything as much as I can within two methods, and not have just one big giant method that does everything. And that way, if I need to target a certain section of the code, I can target that. So I'm going to just make this very simple. I'm going to return dice, because everything's going to be static here. Dice parse and pass the equation. So I'm going to create a static private method called parse. And since I'm within the dice method here, I have access to all those private variables. You don't have access to the private variables outside of your of this particular class here, but I have access to all of them within the class. So everything's going to be static, basically. So we're going to create a static method called parse. And that's going to take the equation. And so this is where all the fun is going to start. So what are we looking for here? Basically what we're going to look at is that, remember, we're going to have two different stacks. And as we take each individual character of the stack, we're going to determine whether we have a number, an operator, or parentheses, or a dice throw, and then place all of those numbers or operators or whatever into the individual stacks. And then once we get to the end, we're going to parse down or collapse the stacks to be able to figure out the actual calculations for the equation that we've done here. And depending upon precedence, we may have to collapse these pieces of stack before we finish the equation, before we finish parsing the equation. And that's, for instance, if we had 1 plus 2 plus 3, we would push 1 onto the operand stack. We would push the plus into the operator stack. We would push the 2 upon the operand stack. The next plus comes in, it will look at the last value on the operator stack, and if it has a lower precedence, the same or higher precedence, then it will then say, oh, I got to stop here. Let's do a computation first. So we'll do the plus sign that's already on there, and we have 1 and 2 in our operands. So we do 1 plus 2. That gives us a 3. We push that back on the operand. And then we continue on. We put a 3. We put the plus sign in the operator. This is the second plus sign. In fact, let's go ahead and just give you an example of how all of these stacks are going to work. Let's start with a very simple equation. Operator, operand. Okay, so here's going to be our equation at the very top. And this is going to be our operator stack, and this is going to be our operand stack. So the idea here is that starting at the very left, we're going to parse out the numbers and the symbols and determine whether they're operators or operands. Remember, operators are going to be your addition, subtraction, multiplication, division, your dice, and your parentheses, while your operands are going to be the numbers. When we encounter the numbers or the operators, we will push them to the stack, and then certain things will happen. So let's go ahead and figure out, first of all, what's going to happen. First of all, we find the number 1. We're going to start parsing from the left, and so we parse the number 1, and we put that on our operand stack. Operands are the numbers. Our next symbol is the plus symbol, the addition symbol. So we put the addition symbol there. Let's get this working nicely here. We'll get this better formatted. Hold on a sec. There we go. Okay. So our next one is an operand. So operands always just immediately get pushed. So our operand gets pushed. So that's our current stack status. Our operators have has one item, which is the plus. Our operands have 2 items, which is the 1 and the 2. We have reached the end. So whenever we reach the end, what we have to do is we now have to what we call collapse the stacks. And the idea here is when we collapse the stacks, we take our operator. So we take the plus sign. The plus sign has been out. We figure out from the plus sign says, okay, I need 2 operands. Okay, so our second operand, we always, since we pushed them, since everything got pushed in and we taken them back out in reverse order from when they were pushed in, our second value in our equation is always the first one we're going to push out, while the first value is the second one we're going to push out. Because, well, I'm sorry, pop out. So when we pop it, we're going to pop the number 2. Well, that was the second value. So that goes after the operator. The first number, we got rid of the 2. The first number, the number 1, is that will be the number that comes before the operator. So what we end up with is the number for the operator, or the second popped number off of the operand. Let's get rid of that. The operator, and then the first number that was popped off. We make the calculation. It's 3. The 3 gets pushed back to the operand stack. Why? Because when we're all completely done, there should only be one value on the operand stack, and that is our final value. So in this case, we've gone through now and we've taken a look and see if there's any more operators. There are no more operators, so we're done. If we have more than one value on the operand stack, we've got an error somewhere. In this case, we have one value on the operand stack, so therefore we have the number 3. And that's our final answer. So what about more complex equations? How about 1 plus 2 plus 3? Well, let's take a look at that. Let's go through that one and see what we have. All right, our first number is going to be, our first symbol is the number 1, so that gets pushed to our operand stack. Our next symbol is the plus sign, so that gets pushed to the operator stack. Our next symbol is the number 2, so that gets pressed to the operand stack. Our next symbol is a plus sign, so that gets pushed to the operator stack. Now, what happens though, whenever operands always get pushed, but an operator, you've got to figure out if there's something already on the stack. And if there is, you may have to make a calculation or not. And this is how precedence works. So right now, a plus symbol has the exact same precedence as a plus symbol. You know, an addition has the same precedence as addition. If this happened to be a -3, in fact, let's go ahead and make that a -3. What the heck? We make that a -3. It also has the same value. It has the same precedence as the addition symbol. So therefore, since they have the same precedence, we have to collapse the stack. So at this point, we're still working on with the minus sign, but we now need to collapse the stack. And as you know from our previous example there, we're going to collapse it by taking the plus sign. We pop off the plus sign. We pop off the first number or the last of the stack on the operand, which will be our second number, and then we pop off the next number, which will be the first number. So that's 1 plus 2 is equal to 3. Our plus sign, of course, we popped off, and our operands, we popped off the 1 and the 2, so that now gives us 3 as the operand. So we've now pushed the 3. So we've done the 1 plus 2. Now we can push the minus sign. And then we have the 3, so we push 3. And now we're at the end of the equation, so now we need to collapse it again. So we're at the end of the equation. We have the minus sign. We pop off our first, let's pop that off. We pop off the minus sign. I have trouble typing here. All right, we pop off the first 3, and that's always our second number. We pop off the next 3. That's always our first number. 3 minus 3 is equal to 0. We push the 0. There is no more equation. There are no more operators. That's our final answer. 1 plus 2 minus 3 is equal to 0, which of course it is. So how does this work with higher precedence? Well, let's just pop the multiplication on there. And parentheses are going to work the same way. I'm not going to show you an example of parentheses. So let's go through the process one more time to show you how the precedence works. Alrighty, so operand. We push our number 1 is our first symbol. We push that as an operand. Then comes the plus sign. We push that. Then comes the number 2. We push that. Then the multiplication symbol comes in. Well, it's going to take a look at the last thing we have on the operand stack is to say, I've got the plus sign here. Well, I've got a higher precedence than the plus sign. And because I have a higher precedence, I'm going to stack myself. I don't calculate what's already there because the multiplication symbol has a higher precedence than the addition symbol. Just like the parentheses even has a higher precedence than both the multiplication and the addition symbol. So because I know there's an addition symbol already on the stack, I'm going to go ahead and push myself there. Okay, so we did the multiplication symbol. Our next symbol is the number 3, so that gets pushed to the operand stack. All right, so now we are finished. The equation is finished. All right, let's start collapsing. All right, so what's our first operator? It's a multiplication symbol. So there's the multiplication symbol. All right, it says it needs 2 operands. So we push the 3. That always goes on after the operator. And we pop the 2. That goes before the operator. 2 times 3 is equal to 6. We push that onto the stack. So that's our new stack. All right, we're at the end of the equation, so we still have an operator available, so we got to collapse one more time. So we take off the plus sign. We pop off the 6, that goes after the operator. And we pop off the 1, that goes before the operator. 1 plus 6 is equal to 7. That goes back on the operand stack. Do we have any more operators? Nope, we don't. Well, do we have just one operand? Yes, we do. That's our final answer, 7. And of course, it checks out because 2 times 3 must be done before 1 plus 2. So the answer to this is not 9. The answer to this is 7. So that's how the stacks work. So the idea here now is that we're going to be creating, as we parse this equation, we're going to be creating 2 stacks. And each of these 2 stacks are going to hold our operators and our operands. So as we parse out the equation, we will then be able to figure out what we need to do. So with all that being said, let's take a look at some code. Alrighty, let's start off with the skeleton of the parse section. So what I'm going to do here is I'm going to take the equation and I'm going to put it into an array, and I'm just basically going to continue to shrink that array down, taking one character off the very top of the array each and every single time so that I know whether I'm going to have a number or I'm going to have an operator or so on and so forth. So this is very much a skeleton of the parsing that we're going to be doing. All right, here's the character split. This is where I basically pop it into an equation. This is the easiest way for me to be able to figure out how to do it. Here's our operand stack. Here's our operator stack. And what I'm going to do here, since I'm parsing it out character by character, I'm going to need to be able to save it if it's an actual number. Now, operators are always one character, whether that's the addition, subtraction, multiplication, division, parentheses, or the letter D. So all the operators are always one character, but numbers, of course, could be multiple characters. And right now, I'm just supporting numbers and a period. I'm not going to no scientific equation or anything like that. If you want to do all that, hey, write it up, do a pull request. I'll pop it in there. It's fine with me. So what are we doing here? Well, we're going to go while the character length is, while we actually have characters in there, we're going to keep parsing it. So we're going to get the character by doing the shift, and the shift basically removes the character, removes the first element of the array. Just like pop removes the last element of the array, shift removes the first element of the array, and I always convert it to lowercase, just in case I want to be able to support a lowercase d or uppercase d. So there's already one test. All right, if it happens to match either a period or a number, I throw it into the number and then go do the next one. Real simple. If it doesn't match a period or a number, it's got to be something else. Okay, if it is not a space and it is not a D, then I'm going to push that number to the operator. I'm going to push the number to the operand stack. Because basically this is what we're going to do here is that if it happens to be a space, obviously I'm just going to completely ignore a space. But if it happens to be anything else, you know, one of the operands or something like that, I need to push my current number, which is inside number, to the operand stack. So that will get pushed to the operand stack when I have a number, and I'm going to reset my number to blank. So at this point, we know that we have an operator. So what's going to happen? Well, we have the D for the dice. We have the left parentheses, the right parentheses, or open and close parentheses. Multiplication and division have the same precedence, so I kept them together. Addition and subtraction have the same precedence, I kept together. Otherwise, we're just going to do nothing. And then once we're finally done, we return the operands. We return the very first operand that's left on the operand stack. So this is just basically something that's very skeleton. It doesn't actually do anything. So let's actually throw some code in there to be able to figure out, you know, to be able to figure out what we're going to need to do when we find an operator. And let's start with the easy ones, which is the addition and subtraction. So let's pop some code in there and let me show you what I've got. Okay, we got some code inside there. Now, what's very important here is, if you remember from the example I did earlier, is that if you have equations like 1 plus 2 plus 3, once a new operator comes in, or we got a new operator that's come in that has the same level of precedence, like for instance a plus and a minus does have the same level of precedence, we're going to need to collapse the stacks, which basically we need to be able to make a calculation saying that, hey, you know, I now need to, if we got an operator in the operator stack, we need to pluck that operator out, pluck out 2 operands, and then do whatever magic we have to do to be able to get a value, pop that number back on the operand before we put our operator on there. So in the case of 1 plus 2 plus 3, we got to figure out 1 plus 2 first before we put the operator on. So we're going to have a private method called CollapseStack, which is going to be responsible for actually figuring out if we need to collapse the stack or not, or just collapsing the stack. Basically, just it figures out if we need to. It doesn't need to figure out if we need to collapse the stack or not. It's going to collapse the stack. And then we're going to push our operator to the operator stack. So let's figure out what we need to do on the collapse stack. So we know that's going to be a static method, and it's going to be private. And it's going to take a number of arguments called stacks. Alrighty, let's throw some code in there. Okay, so what we're going to do here is that we're basically going to go through each of the operators, and as long as we have an operator on the stack, we're going to keep collapsing it. We're going to keep making the calculations to be able to, until we can get down to a single operator or an operand on the stack. And once we're finished there, once we have no more operators, then we're going to return the two stacks back upstairs so that they can do whatever they want to a little bit later on. So that's really all that the collapse stack does. But notice the actual calculation is done inside a static method called collapse. So guess what we got to create here? We got to create a static method called collapse. And it passes the stacks. So let's take a look at that code. Okay, so let's take a look at now the collapse. We've got the code in there. We grab our stacks. If the operand's length plus the operator's length are both equal to 0, that's an error. There must be at least one operand and one operator. And there's nothing around there. We can't get around that. It must be an operator, must be one operand. If the number of operands is set to 1 and the operator length is set to 0, then we just return, because we already have everything collapsed. Because operator length is already set to 0, we're collapsed. There's no need to go any further with it. If the operator length is 0, once it gets out of this point, we know that the operand length is greater than 1. So if the operator length is definitely still 0, then we got a badly formed equation. We got too many operands for the operator. So this starts taking care of some of the errors that we try to test for, all those tests that we did in our previous video. All right, so now we know everything should be okay. So we do a let result, we pop the operator, and then we figure out how many operands it needs. And in this case, there is a mapping, because we're using get there. There's a mapping called number of operands per operator, which again is a static property on dice, and that will tell us how many operands we're going to need for those particular operators. So let's pop that code in there. And I'm just going to cut, copy, and paste that one. All right, there we go. And we basically know that the operator of addition and the operator of subtraction both need two operands. So that will take care of that. So once we get to this particular item, we get our two numbers. We're splicing it off. We're splicing it off of the operand stack, which will take those two entries straight off of the operand stack, and we're also parsing float each one of the different items within the operand stack. So what numbers will end up being is that we have numbers of 0. The number index 0 is our first number, and numbers index 1 is our second number. And that's the reason, because we're not actually popping the data off of the stacks, we're splicing it off of the stacks. So I'm physically taking those two numbers, or one number, or whatever, from the end of the stack. So then we just switch the operator. If we have addition, we add them together. If we have subtraction, we subtract them. And remember, once we have our result, we push it back to the operand stack. Always. We always push our final number back to the operand stack, because there could be more operations that need to be done. And then we're going to return our operands and operators. And I believe that's basically it. So that will take care of this section in our CollapseStack. And we're going to return operators. That's going to take care of this section to make sure it returns correctly. It returns correctly. And we're going to do another push. We're going to push the operator as we have gone. We're going to push the operator as part of the equation parsing process. So what happens when we're done? Well, that's a very good question, because we got to try to figure out. We just can't return operands as 0, because if we're done, we have a number that's probably still out there. Because if we have, let's go back to our equation at the very top here. If we have 1 plus 2 times 3 and we're finished, we still have 3 sitting out there doing nothing. So let's pop some code in there of basically a cleanup code that needs to be done after the equation has finished parsing. All right, and here's our code. So for example, if we actually have a number out there, and then we will push the number, and then we got to do a collapse stack one more time. And that will collapse the entire stack for us. We should end up with just one operand. If we don't end up with just one operand, we throw an error saying the equation is malformed. Otherwise, we'll return that single operand. And that should be it. Our addition and subtraction should automatically work now. All the rest of them are not going to work, but the addition and subtraction should. So, you want to see what they do? Let's figure it out. Let's see what happens. Let's clear off the screen. Let's do npm run test e2e ci. Now, if I just did E2E, that does the Cypress open, and we can do it interactively with the E2E:ci. This does it within the console window here, so I can see the result. I can see the result within the console. So we'll run that, and I'll see you on the other side. And we're done, and would you look at that? Addition now works, and subtraction now works. So this process that we have here, this parsing of the different equations, at least works with the addition to, in relation to addition and subtraction. So let's throw some more fun things in there. How about multiplication and division? Well, that should be a fairly easy thing to do. Let's throw that in there and see what happens. All right, so multiplication and division. This is where the precedence now starts to come into effect, because the idea here now is that I need to basically take a look at the precedence of what is already on the operator list. And if it is a lower precedence than I am, then kick it out. I don't want to have to deal with it. Now, looking at this code right now, I wrote this code originally about a month and a half ago or so, but looking at it right now, this is actually the wrong way of doing it. So basically what I've done here is I've got a plus or minus on here, and basically I'm saying if the what's already on the operator stack, the current one that's on the operator stack, or the last one's on the operator stack, if that happens to be a plus or a minus, then negative one means if it happens not to be a plus or a minus, then I go ahead and collapse the stack. But if it is a plus or minus, I have a higher precedence, so I'm going to push my multiplication or division onto the operator. So let's actually fix this while we're here. Like I said, that sucks the way to do it. What we really need is a static property called Precedence. Precedence. I hope I spelled that right. So the idea here is that we're going to actually now look up the precedence based upon the values that are within the operator stack and our current value. So the plus sign is going to have a precedence of 1. The subtraction is going to have a precedence of 1. Multiplication is going to have a precedence of 2. Division is going to have a precedence of 2. The left parentheses is going to have a precedence of 3. The right parentheses is going to have a precedence of 3. And the fact of the matter is, I don't have one for dice. We're going to call dice 3 for right now. Like I said, we're just writing this code for the first time. So now we're going to have a private method called, a private property called precedence is going to give us our precedence values. This is the better way of actually running precedence. So I really don't care about the. Actually, I do care. I do care about this. Let's do this right. Let's do the character. Let's do everything correct here. So there. Okay. I know the duplication of code right there. We'll worry about that a little bit later on. But now this should work out a little bit better. Unless we got some errors here. So we've set our current precedence. But we've got a map up there now that gives us a precedence. So we get the current precedence of that. We get our stack precedence, which will always be a 0. So our current precedence, if there's nothing on the stack, our current precedence is always going to be bigger. So we'll stack it no matter what. If the current precedence is less than or equal to stack, we collapse it. Same thing here. And I know it's duplication of code. Code smell, beep, beep. But we'll have to worry about that. In fact, heck, you know what that really means is that we can now do that. Gosh, this code's getting better and better all day. Okay, that works a heck of a lot better. So there we go. Now, because they all follow the same way, now we're getting precedence. It's all the same code. That should work out. So that should do it. That should get the multiplication, the division within the code also. That's called. This is called programming on the fly here. Once you take a look at it and say, yeah, that sucked. You could have done a lot better than that. So now it works out. That should work a little bit better. We got our precedence up here. Now we can combine all 4 of those into the same code, but we're going to need to make sure that we support multiplication and division down at the bottom here. So let's throw the code in there to be able to do multiplication and division. And that's real simple. We multiply numbers and divide numbers. So unless we made some stupid errors at the top there, which if you know me anytime soon, stupid errors come with the territory. Yeah, no. Our test should work. Let's find out. I'll see you on the other side. Okay, we're all done here. The addition and subtraction still works. Multiplication and division does not. Some of the tests passed, but some of the other ones did not. So let's see what we've got here, just in case. Alrighty. That's precedence. We know precedence isn't going to work. Okay. Hey, look at that. That worked. Cool. Alrighty, let's see what else we got here. Running parentheses. We're trying to find, there we go, running multiplication. So, should throw error if the multiplication is by itself, and should throw an error if if it's first the equation or last in the equation. Otherwise, otherwise it does actually do the multiplication correctly. So, we've got to figure out here why the multiplication by itself or being first equation or last equation failed. And I bet you the division is the exact same thing. Yeah, division is the exact same thing. So what's interesting is that we got that the addition and subtraction worked great, but multiplication and division did not. And I wonder why that possibly could be. So let's take a look at the code and see if we can figure it out. Okay, and the reason it did that is that we forgot to add information here at the number of operands per operator. So that would probably help to add those two things in. And there we go. So now we got the multiplication and division in there, because now it has a number of operands per operator. It can figure out what the heck to do. Kind of strange that it figured out, it did the calculations correctly, but it didn't know how to do the number. It didn't. Anyway, it doesn't matter. Well, let's run our test again and see if that was the problem. Let's run our test again and see what happens. And I'll see you on the other side. Okay, we're all finished up here. And yep, oh, division and multiplication actually now work fine. So that gets us addition, division, multiplication, and subtraction. What should we work on next? Well, I think the precedence might be the, well, precedence also deals with parentheses, and we don't have parentheses yet. So let's go ahead and deal with parentheses next. All right, so let's take a look at it and see what kind of stuff we're going to need to do on our parentheses side. So basically, we're needed to be able to support both the open parentheses and a closed parentheses. Now, the open parentheses is going to have a higher precedence, as we've already set here. So what will happen is that let's go to our board here again. So if we said 1 times 2 plus 3, let's see what's going to have to happen on the parentheses, because that works a little bit different. All right, so our first number, our first entity is the number 1. Then we have multiplication. Then we have a open parentheses, which means that open parentheses is a special case. If I was to put a plus sign here, it should error out saying it can't have two operators next to each other. But what I'm going to do here now is I'm going to have a, I just realized I didn't test for that. We'll have to try to test for that. But the thing I want to do here now is that when we encounter the open parentheses, that's going to be pushed or thought of as an operator. It has a higher precedence than the multiplication symbol, so therefore it gets pushed. All right, the number 2 is going to get pushed next. Then the plus. The plus has a lower one, so it should execute the open parentheses. But here's something special about parentheses, is that once we get to the CollapseStack, it's going to sit there and say, oh, hey, I've got an open parentheses here. Basically, I need to execute everything within the open parentheses and figure out and close that one out before I do anything. So I'm just going to stop. I'm going to pretend that the open parentheses is the end of the stack. Because if you think about it, everything within the parentheses is calculated first. So if you think of the parentheses being its own individual stack, then you don't ever have to worry about the parentheses. You don't have to worry about the parentheses messing up. So if you think of the parentheses as its own individual stack, we will have the CollapseStack to be able to stop when it encounters an open parentheses. So the plus sign gets automatically put on top. So you already know we're going to enter into a problem. Well, we're not going to enter a problem, but that's no big deal. In fact, I just thought of something else I need to refactor on this code, but it doesn't really matter. Okay, so I got a plus sign there onto the operator. Our next number is going to be the 3. So the 3 gets pushed. Then the closed parentheses comes in. So what's going to happen when a closed parentheses comes in? That's going to be a little different. A close parentheses basically is going to say, that's kind of, if you think about it, is the end of the equation for that parentheses. So we're going to have the stack be able to say, hey, we're actually closing parentheses here, so you need to keep on going until you find an open parentheses, but stop when you find an open parentheses. So it's going to basically then do the plus. So it's going to have the open, so it's going to know it's going to have the closed parentheses. So it's going to execute a plus, a 3, and a 2, and that's going to equal 5. So that gets eliminated. That gets eliminated. That's our current situation now. Since the open parentheses is right next to the closed parentheses, that can be completely eliminated too. And now we're back to 5 times 1, which will be 5. Real simple, right? Aha, good. So let's go ahead and take care of that next. All right, if it is a greater than, if it is an open parentheses, then we're just basically going to push it. I'm not even going to take a look at, I'm not even going to worry about the precedence. I'm just going to flat out push it because it's going to be the highest precedence possible. All right. How about a closed parentheses? All right. Well, a closed parentheses, whenever we have a closed parentheses, we're going to have to collapse this. We're going to collapse the stack. And so let's throw some code inside there. And boy, I just thought of a really far better way to be able to refactor all of this. But hey, we will deal with that. We'll deal with that a little bit later. In fact, that'd be a great third video. That would be a great that would be a great third video. This is a very simple video. That'd be a great third video. We'll refactor this thing to make it far better. But for right now, that's the way it is. So what we're going to do here is we're going to call CollapseStack to have another property or another argument called true. And if it's true, that means that it is working with a closed parentheses. And so CollapseStack is going to do something special based upon the closed parentheses. But once everything is done, there's still going to be an open parentheses left on the operator stack. So we're going to pop the open parentheses off of the operator stack. So let's go ahead and go to the CollapseStack. We're going to have some changes down there to be able to get it to work correctly. Like for instance, the first thing we're going to need to do is we're going to need to change the declaration of it to include closed parentheses. Closed parentheses now is equal to false. So now we're going to be, instead of just going through the operators, we're going to have a little bit more code there. So let me pop that code and show you what we have. So just a little bit more code. The idea here now is we're still doing the while lengths, but we're also while it is not equal to a open parentheses. So basically we want to stop as soon as we get to an open parentheses. Otherwise we collapse it as we normally do. If we are looking at closed parentheses and we have and there is no more open parentheses, because collapse will also collapse if there are, if there's no more operators left, then we have a mismatch error, mismatch parentheses. So that's how we figure out the mismatch part. So that should cover the parentheses for us completely. Make sure I got that correct. Yeah, because we're not doing any calculation or anything. We're just basically telling it how to figure out, where to stop when it's trying to collapse it. So the big thing we're doing here is that instead of just collapsing all the way down to nothing, we're collapsing down to nothing, or we're collapsing with a or we're collapsing if the operator has if we encounter a open parentheses. So that should be it. Let's save it and let's run it. Let's see if the parentheses works now. We'll see you on the other side. Okay, and yeah, we got it. There it is. Parentheses now works for that. And again, we got I just thought of a wonderful way to refactor all of that. That's going to make it a heck of a lot better than the kludge that I put inside there. Big code smell. All right, so we got all of that done. Let's tackle the dice. And let's see if we can get that dice all nice and pretty. So let's tackle the dice. Dice is a whole different ball of wax. In fact, even now I'm sitting here thinking, oh, I know how I can refactor this one and make it work a little bit better too. But again, we're going to go with what we have. And let's start working with it. All right, first of all, number of operators. Let's take care of that first because that was our error from last time. So let's close that out. and we'll make D have a number of operators of 1. There we go. I don't know why it's doing that. Oh, that's right, because I have a two those. Okay, never mind. All right, so number of operators for our dice is 1. All right, let's do the dice. Now this is a little bit more complicated, so let's show you exactly what we're doing here. So for the dice, first of all, we want to make sure that there's actually a number there. If we have not encountered a number yet, we want to assume a number 1, because remember the first number, when we encountered the letter D, we should already have a number available. And if there's not a number available, we have to assume a 1, because in our case, that XDY formula, X is optional. All right, we're going to push. What we're going to push here is the number, dash, and our letter D. And then close out the number again. And the reason we're doing that is that this is on the operators things. The reason we're doing that is that the D is a special case in which it only takes one operator, but the operator, it only takes one operator, but this operator may have an optional number associated with it. So we're saving the optional number in the operator stack, and we'll take care of that when we get to the CollapseStack section. So that takes care of the D part on the parse. Now, there's nothing additional we want on the CollapseStack because it's still CollapseStack, but there's going to be some big changes on the collapse itself. All right, so let's take a look at some of the things we're going to need to have. All right, so let's pop a die number inside there. We're going to need to have some sort of value to be able to determine what our current die number is. And then we're going to need a way to find out if our operator, we're popping our operator off the stack, if our operator is a D operator, which basically says, hey, if we have the letter D inside there, then we are splitting up die number and operator from the, we're splitting up the value and getting the die number and the operators. This is the number of dice and the operator itself. So now die number will be equal to 1, 2, 3, 4, 5, 6, or 7, or whatever, because when we pushed it, we pushed it like that. So, all right, die number and operator, we got those two numbers, so that's great up there. We're getting the number of operators, no problem there. So let's actually do the dice calculation, and this one is going to be slightly long here. So let's do the dice calculation. Okay, so how are we going to do this? Well, first of all, numbers is going to be only one array long because we've said we just want one operand per operator. And so when we go back to that, we're going to, we grabbed it from here, and now we're going to unshift it, which means we're basically going to place back onto the numbers. Yeah, I said unshifted correctly. It's dialed that correctly. We're going to pop onto numbers to the very beginning, the number of dies that we currently have. So numbers is 1, and numbers will contain the sides of the dice. When we do the unshift here, we're going to pop onto numbers at the very beginning, the number of dice. So numbers of 0 will be the number of die, and numbers at 1 will be the number of sides. Okay, so we want to make sure that both integers, or throw the error, we want to make sure that numbers of 1 is less than or is greater than or equal to 2, that numbers of 0 is greater than or equal to 1. Otherwise, we do the result, and we just do a very simple little loop through to do our random number. And we're doing a math ceiling here, so we'll get a number between 1 and the number and not 0 and the number. Because remember, math.random will give you a number between 0 and 1, not including 1. So it's actually 0 and 0.99999999999 whatever, but it never give you 1. So whenever we multiply it by the number of sides here, for instance, of 6-sided die, we're going to get 0 to 5.999999999, or whatever the number be. We'll never get 6. But by doing a math ceiling basically says take the integer number of the value and then add 1 to it. So between 0 and 5.9, the integer number, the integer part of that will be 0 to 5. We add 1 to it, gives us 1 to 6. So math.ceiling is going to give us our correct number. And we just keep adding that to result and in break. And once we're finished, we push results to operand and return the operands and the operators. So that should take care of that. So it's real simple how it's done here. And I know a much better way of doing it that I thought about here. So again, to recap very quickly, what we're doing is that we're pushing onto the operator stack both the number of dice and the character itself, or the die character itself. We're splitting that back up here. And then if it happens to be a dice, we're going to add the numbers to numbers of 0 and then do the calculation down here as normal. And that should be it. There should be nothing else to add. So let's take a look. Let's run our test. I'll see you on the other side. Okay, we're done, and yep, our die roll works great now. All we have to do is to figure out the precedence of it. Let's see exactly how many tests failed. Actually, only one test failed in the precedence. So if you take a look at it, we've only got one test where it is. It should return a correct result with D and other operators. So it looks like that our dice is not cooperating correctly with, or we're not working correctly with all the other operators. So we need to figure out exactly what has gone wrong on that. So let's go back to our precedence test. Should return a correct result with D and other operators. What are we checking for here? All right, 3d6 plus 100. All right, so let's figure out exactly what may have happened with that. Let's go back to our dice code. All righty, what was the expected value? Okay, it actually asserted expected false to be true. So it looked like it actually died on me for some reason. That's interesting. Well, let's figure out exactly what may have gone wrong with that. All right, let's just walk through it. Okay, so we got the numbers. We push the number. We push the numbers. We do our current precedence and our stack precedence. I wonder if that might be the problem there. Well, no, because we don't worry about precedence on those numbers. Okay, our precedence on the numbers looks like that they may have now are messing up how the D is being done. That's what I'm thinking at this particular point in time. We did a 3d6 plus 100. Let's just walk through it. We did the 3. So we did the 3d, so number came up with 3, so we pushed a 3-d to the stack and did the break, and then we did the 6. Okay, so we did the 6 number. That got, and then we did the, was it plus 100? Let's take a look at precedence. Yeah, plus 100. So we didn't do it plus. So the star, so the dash, this number dash D is on the operator. So if operator length, so we try to get it, it's going to return to be null. Otherwise it's going to be a 0. Now that's interesting. So our stack precedence is now going to be null. So when the plus comes in, if the current precedence is less than stack precedence, but if they don't combine, oh yeah, so this is interesting, because now the problem here is that the D actually needs to be of a lower precedence. Well, no, because that's going to come out null. And if that comes out null, how is 3 less than or equal to null? That is false. And because that is false, we don't collapse the stack. And yet we need to collapse the stack, because what we'll end up with, let's go back to our numbers. What was it? It was 3d6 plus 100. So our operator is going to be 3d, and our operand is going to be 6, and it's going to be false. So it's going to add itself on there. So then it's going to go 100. And then basically what's going to have to happen is that it's going to then say, when it collapses, it's going to add 106. And then it's going to have that 3D, which is not going to be valid. So it's going to blow up on us in that case, because we'll have an operator with that operand. So that's what's happening here. Our problem here is our stack precedence is incorrect. So what we can do here is also do that. And basically what that will mean here is that our operator, if this comes out to be null, which it will if we have our dice there, then this section is going to count to be null, and you'll need to use the nullish coalescing operator to be able to say, hey, if it happens to be null, change it to 0. So let's see if that works. Let's just do a quick test here. Yeah, okay, that should work. All right, so let's run our test. Let's see what happens. I'll see you on the other side. Okay, we're all done, and I'm still getting an error. What's the error there? All right, still should return the correct result with D and other operators. So it's still throwing an error. It's still messing us up there. So what in the heck could be happening? Because of if the stack precedence is 0, then when we have the multiplication down there, our current precedence is less than or equal to, fudge. Okay, so we should null coalesce. If it ends up being null, we actually need to null coalesce to 4. And if it can't get it, it should also be 4. It should be highest precedence possible. I think that's our problem right there. Yeah, we're definitely going to be doing some refactoring here for the next video. So let's clear up the screen. Let's run, and I'll see you on the other side. Okay, we're back in. Yay! That was the problem. The parentheses now works. Well, we do definitely have some code smell in there, but our code now completely works. So I think our next video actually is we're going to do a little bit of refactoring on the CollapseStack, and we're going to do some refactoring on on the parentheses, and we're going to do some refactoring on the dice itself, because it really sucks the way I'm doing it. A real bad code smell. There's a lot cleaner way of doing it, and we'll do that next on the next video. So that's it for the dice. All our code works. It runs like a champ. You can now say dice.roll, give it an equation, and it will roll any kind of dice you wish, with full support for an equation for addition, subtraction, multiplication, division, and parentheses. And so, of course, if you want to add other things like exponentiation, all that kind of fun stuff, it should be easy to add. If you like this video, please click on the like button below, subscribe to this channel, or leave a comment. I would love to hear from you. And again, thank you so very much for watching. This is the Virtuoid, aka Mike Smith. We'll see you later.